picture the quietest room you have ever been in, not the silence of a library, not the hush of a church. The real thing. A room where the air itself seems to weigh something, where the only sound is the blood moving through your own ears. Now hold that feeling, because what we are about to do is not going to give it back to you. In 2018, 2 scientists published a question, not an answer, a question. And it is the kind of question that, once you genuinely sit with it, never fully leaves the back of your mind. Not because it is sensational, not because it traffics in aliens or ancient gods or conspiracies that belong on a corkboard connected by red string, but because it is rigorous, peer-reviewed, published in the International Journal of Astrobiology by Adam Frank, astrophysicist at the University of Rochester, and Gavin Schmidt, climate scientist and director of the NASA Goddard Institute for Space Studies. The question they asked was this: if an industrial civilization existed on Earth millions of years before our own, would we even be able to find it? Read that again. They were not asking, did one exist? They were asking something far more unsettling. They were asking whether our science, our geology, our archaeology, our understanding of the Earth itself is even capable of detecting the evidence if it had. And the answer they arrived at: probably not. Here is what that means in practice. Look at what we are doing to this planet. 300 million tons of plastic produced every year. Over 2,000 nuclear weapons detonated since 1945, leaving radioactive scars in the soil and the ice. A carbon isotope signature in the atmosphere so distinct that geologists can read it like a fingerprint. A mass extinction event currently underway that rivals the 5 great die-offs of the deep past. If our civilization collapsed tomorrow and something intelligent evolved 50 million years from now, they might find a thin, strange chemical layer in the rock. A whisper, not a shout, a whisper. Now, here is the part that keeps the lights on at night. When Frank and Schmidt looked at the deep geological record, the actual rock, the actual chemical data, they found exactly that kind of whisper. Anomalies, events that, from a chemistry standpoint, look disturbingly like what we are doing to the Earth right now. Events that have perfectly reasonable, scientific explanations. Events that we may simply be incapable of distinguishing from the fingerprint of something that should not exist. Tonight, we are going to follow the evidence. We are going to look at the geology, the archaeology, the climate science, and yes, the oldest stories humanity has ever told. We are going to visit a temple that predates agriculture by 6,000 years. We are going to ask why the most famous monument on Earth shows signs of being battered by rain in a desert that has been bone dry for 5,000 years. We are going to find evidence of a cosmic catastrophe that may have ended something. And by the end, you are going to have to decide for yourself. Are we the first, or are we the second try? Before we can understand what might be hidden, we need to understand the machine that does the hiding. The Earth is not a museum, it is a furnace, and it has been running continuously for 4.5 billion years. Let us actually feel that number rather than just read it. 4.5 billion years. If you compressed the entire history of the Earth into a single calendar year, the dinosaurs wouldn't appear until mid-December. The mass extinction that killed them would happen on December 26th. Our entire species, Homo sapiens, everything we have ever been, shows up at approximately 11:58 p.m. on December 31st. Our industrial civilization, the last 4 seconds of that year. 4 seconds out of 365 days. In all those billions of years, during all those eons when complex life walked, swam, and breathed on this planet. Is it really conceivable that intelligence only happened once? Think about that from an evolutionary standpoint. Complex animals have existed for over 500 million years. Mammals have roamed the Earth for more than 200 million. Dinosaurs dominated for 165 million years, more than 500 times longer than we have existed as a species. Some of them had relatively large brains. Some lived in complex social structures. Some showed signs of problem-solving behavior that, in a mammal, we would flag as significant. We went from stone tools to smartphones in approximately 12,000 years. What could 165 million years produce? The math alone demands that we at least ask the question. But asking the question immediately runs into a wall. Because the Earth is astonishingly efficient at destroying its own history. Here is what happens to a civilization if you give the planet enough time. In the first decade after collapse, power grids fail, vegetation reclaims roads, the machines go quiet. In the first century, wooden structures rot and collapse. Steel infrastructure rusts through. Glass shatters under decades of thermal stress. By the first millennium, most surface structures have been reduced to rubble. That rubble is being buried under accumulating sediment, soil, wind-blown material. The ruins are becoming geological events, compressed into layers, chemistry mixing with the surrounding rock. By the first million years, tectonic processes have begun resurfacing entire regions. Rivers have changed course. Coastlines have migrated. Subsidence and uplift have tilted the land. The specific locations where cities once stood are no longer identifiable from the surface. To find them, you would need to drill. You would need to stumble upon a cliff face, a natural cross-section that happened to slice through exactly the right sedimentary layer in exactly the right spot. By 10 million years, subduction zones have pulled large sections of ocean floor and everything on them down into the mantle. At temperatures of 1,300 degrees Celsius, rock melts, steel melts, concrete melts, glass melts. The atoms that made up a skyscraper are now indistinguishably mixed into magma that will eventually resurface somewhere else as new volcanic rock, carrying no memory of what it once was. By 50 million years, virtually nothing physical survives. No structure, no artifact, no fossil. The conditions required to fossilize a bone are exquisitely rare. The creature must be buried quickly, in the right sediment, with the right chemistry, before it decays. Across the entire reign of the dinosaurs, spanning 165 million years, the total number of individual fossils we have recovered could fill a single museum. One building for 165 million years of life. A civilization that existed for a few thousand years would be lucky to leave one fossilized individual, and that individual would tell us nothing about cities or agriculture or technology. Frank and Schmidt named their thought experiment after a 1970 episode of the British science fiction show Doctor Who, a story about a race of intelligent reptilian creatures called the Silurians, who supposedly lived on Earth before humanity. They borrowed the name with a wink. They were not claiming lizard people built cities in the Jurassic. They were making a much more precise, much more disturbing argument. What they argued is that the geological record of Earth, the only archive we have of deep time, has fundamental blind spots. Not because we have not looked hard enough, but because the Earth itself is the archivist, and the Earth does not preserve things it is not designed to preserve. We are trying to read a book from which 99% of the pages have been torn out. The surviving pages have been water damaged and partially burned, and the language may have changed since it was written. What we are left with, the only things that could theoretically persist across tens of millions of years, are chemical signatures. Isotopic anomalies, thin layers of unusual element concentrations sandwiched between otherwise ordinary rock. And here is the key insight Frank and Schmidt drove home. Those chemical signatures would look almost exactly like natural geological events. A spike of carbon in the atmosphere looks like a volcanic eruption. An isotopic anomaly in the rock looks like a hydrothermal event. A layer of unusual heavy metals looks like a meteor impact. There is no clear line at this resolution between a civilization burning its way through the fossil record and a series of entirely natural geological processes. This is not fringe science. This is a formal analysis of the limits of our own detection capability. And those limits are severe. Less than 1% of the Earth's surface is currently urbanized. If our civilization ended today, and something intelligent searched for us 50 million years from now, they would be sifting through core samples representing less than 1% of the original surface. Of that fraction, most of the ocean floor, 71% of the planet, would have been recycled by mid-ocean ridges and subduction zones. The oldest ocean floor currently in existence is about 200 million years old. Everything before that has been melted. The surviving continental crust is older, but exposed, undisturbed surface from before the last 2.5 million years is vanishingly rare. Erosion, sedimentation, volcanism, glaciation, metamorphism, all of these processes resurface the land on geological timescales. And then, and this may be the most critically underappreciated factor of all, there is sea level. During the peak of the last ice age, roughly 20,000 years ago, sea levels were approximately 120 meters lower than they are today, 400 feet. The coastlines of every continent extended far beyond their current positions. Enormous tracts of what is now continental shelf, warm, shallow, biologically rich coastal land, were exposed and habitable. Where do civilizations develop? Not in the deep interior, not on mountaintops. They cluster along coasts and rivers, along the paths of trade and communication, along the places where fresh water meets salt water and where marine life is abundant. If a civilization existed during the last ice age, it was almost certainly coastal. And those coasts are now under the ocean. Under 120 meters of water and 12,000 years of marine sediment, largely unexplored. We have spent billions of dollars exploring the surface of Mars. We have sent orbiters to Jupiter. We have, as of the time of this recording, mapped less than 25% of the ocean floor with high-resolution sonar. If the evidence exists, it is down there, and we have barely looked. So now we have the framework. We understand the limitations. We understand why absence of evidence does not mean evidence of absence, especially in a system specifically designed to destroy evidence over time. Now let us look at what we actually find when we look at the deep record. Let us look at the most extraordinary anomaly in the last 66 million years of Earth's history. A scar, 56 million years old. One that has no fully satisfying natural explanation. One that looks, from a chemical standpoint, disturbingly familiar. 56 million years ago, something happened to this planet that geologists and climate scientists have been arguing about for decades. There was no crater, no single massive volcanic eruption, no asteroid. There is no smoking gun that fits neatly into the existing framework. What there is, in every core sample pulled from the planet during this period, whether from the bottom of the Atlantic Ocean, Arctic permafrost, Antarctic ice, or limestone outcrops in New Jersey, is the same signature, a sharp, unmistakable chemical disruption that geologists call the Paleocene-Eocene thermal maximum. The PETM. If you have never heard of it outside of geology departments and climate research laboratories, that is not an accident. It does not make for comfortable headlines. Because once you understand what it looks like, chemically, climatologically, ecologically, and once you know what we are currently doing to the planet, the comparison is not easy to dismiss. In a geologically brief window, estimates range from 6,000 to 20,000 years, which is an eye blink in deep time. An enormous quantity of carbon was injected into Earth's atmosphere and oceans. Current research places the total at somewhere between 3,000 and 13,000 petagrams of carbon. Let us translate that into something useful. Humanity has released approximately 580 petagrams of carbon since the beginning of the Industrial Revolution. 580. The PETM released, at minimum, 5 times that amount. Possibly as much as 20 times. The result was a planetary fever unlike anything the Earth had experienced in the preceding 66 million years. Global average temperatures rose by 5 to 8 degrees Celsius. That number requires context. The current international conversation about climate change is centered on preventing a rise of 1.5 to 2 degrees. 5 to 8 is a different Earth. The Arctic Ocean reached temperatures of 23 degrees Celsius. Subtropical warmth spread to the edges of what is now Antarctica. Crocodile relatives lived above the Arctic Circle. The tropics became nearly uninhabitable. Ocean surface temperatures off the coast of West Africa reached 36 degrees Celsius, 97 Fahrenheit, a temperature at which marine organisms cannot survive. The deep ocean lost much of its oxygen. The technical term is anoxia. The plain language meaning is suffocation. Creatures living on the ocean floor died in enormous numbers. It was the largest deep-sea mass extinction event of the last 93 million years. Meanwhile, calcium carbonate dissolved. Shell-building organisms, corals, creatures that depend on mineral structures to survive. They were devastated. Their shells literally dissolved as the oceans acidified. On land, rainfall patterns shifted violently. Entire biomes were reorganized. In the Bighorn Basin of Wyoming, which holds one of the most detailed terrestrial records of this era, the entire mammalian fauna turned over. Species that had been present for millions of years vanished. New species appeared, adapted to the new heat. The landscape from top to bottom was remade. Then, over the following 100 to 200,000 years, the Earth slowly healed. Carbon was drawn back down, temperatures fell, the oceans recovered, life adapted and moved on. What remained was the scar, a thin band of unusual chemistry in the rock, a geological whisper. Mainstream science has several leading hypotheses for what caused the PETM. They are not mutually exclusive. The most widely supported involves massive volcanism associated with the North Atlantic Igneous Province, an episode of intense volcanic activity as Greenland and Europe rifted apart. The theory suggests that magma intruded into carbon-rich sedimentary rock, essentially baking it and releasing enormous quantities of carbon dioxide and methane. Mercury anomalies in the sedimentary record from this era support this idea, since Mercury is a reliable geological proxy for volcanic activity. A second hypothesis focuses on methane hydrates, ice-like structures on the deep ocean floor that trap vast quantities of methane, a greenhouse gas far more potent than carbon dioxide in the short term. If ocean temperatures rose even slightly, these hydrates could have destabilized in a cascade. Initial warming releases methane, which causes more warming, which releases more methane. A feedback loop, a runaway. A third involves orbital forcing, changes in the shape of Earth's orbit and the tilt of its axis that alter how much solar energy different regions receive. Evidence suggests the PETM onset coincided with an extreme orbital configuration that concentrated solar energy unusually. Most researchers today believe the PETM was caused by a combination of all three. Volcanic activity provided the initial carbon pulse, or orbital forcing amplified the warming, and methane hydrate destabilization drove it into overdrive. These mechanisms explain most of the observed data. Most of it, but not all of it. Here is what Frank and Schmidt were careful to highlight, without making claims they could not support with the existing data. The carbon isotope signature of the PETM onset, the ratio of carbon-12 to carbon-13 preserved in the sedimentary record, shows a sharp negative shift. This shift indicates that the carbon that was released into the atmosphere originally came from living organisms. From biological material, coal, oil, and natural gas are biological carbon. They are the compressed remnants of organisms that died hundreds of millions of years ago. When you burn fossil fuels, you are releasing carbon with a very specific isotopic fingerprint. A fingerprint that is, in fact, strikingly similar to the fingerprint we see at the PETM boundary. Does that mean an industrial civilization caused the PETM? No, absolutely not. The volcanic and methane hydrate explanations are far more parsimonious. Frank and Schmidt said so explicitly. But here is what they also said. If such a civilization had existed and had burned through its fossil fuel reserves in a manner similar to our own, the chemical signature it left would look very much like what we see at the PETM. The two signals would be, in many cases, indistinguishable, and that is the uncomfortable part. Not that the PETM was caused by a civilization, almost certainly it was not, but that if it had been, we might not be able to tell. There is a deeper paradox embedded in this. The more sustainable a civilization is, the smaller its footprint. A society that runs on solar and geothermal and wind energy leaves essentially no trace in the geological record. A society that burns massive amounts of fossil fuel leaves a trace that looks exactly like a natural carbon release event. And a civilization that rises and falls within a geologically brief window, say a few thousand years, leaves a signal so thin it would be lost in the gaps between core samples. We are looking for a needle in a haystack, but the needle is made of the same material as the hay. The PETM lasted roughly 200,000 years from onset through recovery. Our industrial civilization has existed for 300 years. If something analogous to us had existed 56 million years ago, their entire rise and fall would occupy a layer of sediment thinner than a sheet of paper. In many core samples, that layer would not be preserved at all. We are left with a scar, an ancient scar in the rock, and a question that does not have a comfortable answer. But the PETM is not the only scar. If you fast forward from 56 million years ago to a moment far closer to our own, 12,800 years ago, to be exact, you find another event, another catastrophe, another disruption that standard explanations struggle to fully accommodate. And this one did not just leave chemical traces. This one left bodies. 12,800 years ago, the world was thawing. The great ice sheets that had covered much of North America and Northern Europe for tens of thousands of years were retreating. The climate was warming steadily. Woolly mammoths still moved across the tundra in herds. Saber-toothed cats hunted in forests that were only just beginning to green. Giant ground sloths, creatures the size of modern automobiles, grazed in woodlands that stretched from what is now Alaska to Patagonia. In North America, a culture of extraordinarily skilled hunters flourished. We call them the Clovis people, named after a site near Clovis, New Mexico, where their artifacts were first formally identified. Their stone spear points, fluted, symmetrical, technically precise, represent some of the finest knapping work in the prehistorical record. These were not primitive people. They were sophisticated hunters operating with an intimate knowledge of their landscape and their prey. The ice was retreating. The future, if that word has any meaning in that context, looked open. Then, in what appears to be the span of a single human lifetime, everything changed. The megafauna, the large animals, disappeared. Not gradually, not through slow attrition over millennia. They vanished from the fossil record in what is, at the resolution of geology, an instant. In North America alone, 35 genera of large animals went extinct. Mammoths, mastodons, giant ground sloths, short-faced bears, American lions, saber-toothed cats, dire wolves, giant beavers the size of black bears, American camels, American horses, an entire ecological world gone. The Clovis culture disappeared at the same time. Their distinctive tools vanish from the archaeological record. Whatever replaced them was different, simpler, as though the knowledge and the cultural continuity that produced those beautiful fluted points had been interrupted, broken, lost, and people were rebuilding from something less than scratch, and the climate reversed. Temperatures that had been rising for thousands of years plunged. In parts of Greenland, annual average temperatures may have dropped by as much as 10 to 15 degrees Celsius, not over centuries, but within decades, possibly within years. The warm period ended. A cold snap called the Younger Dryas, named for a small Arctic wildflower whose pollen suddenly reappeared in European sediments, lasted for approximately 1,200 years. The mainstream scientific explanation for the Younger Dryas cooling has long been oceanographic. The theory, a massive pulse of cold freshwater from melting glaciers in North America, possibly from the catastrophic draining of an enormous glacial lake called Lake Agassiz, poured into the North Atlantic and disrupted the thermohaline circulation. This circulation, sometimes called the Atlantic Conveyor, carries warm tropical water northward and is responsible for keeping Europe and the North Atlantic relatively mild. Flood it with cold fresh water and the conveyor shuts down. The warm flow stops. Europe freezes. This is a solid theory. It is well supported by oceanographic data. It explains the climate reversal, but it does not explain the simultaneous extinction of megafauna across multiple continents. It does not explain the disappearance of the Clovis culture, and it does not explain what researchers began finding in the sediment layer precisely at the Younger Dryas boundary, a layer that contains things that should not be there. In 2007, a team of approximately 20 researchers, led by Richard Firestone, Alan West, and colleagues presented findings at the American Geophysical Union that electrified and polarized the scientific community. They had found, at multiple sites across North America, a distinct sedimentary layer dating to approximately 12,900 years before present. And this layer contained an assemblage of materials that did not belong in ordinary sediment. Nanodiamonds, microscopic diamonds measured in billionths of a meter, that form only under conditions of extreme heat and pressure. The kind of conditions generated by cosmic impacts, nuclear explosions, or objects striking the Earth at hypervelocity. Magnetic microspherules, tiny metallic balls that form when rock or soil is melted and then rapidly resolidifies in midair, a process that occurs during aerial explosions or impacts. Iridium, an element that is extraordinarily rare in the Earth's crust but common in asteroids and comets. Shocked quartz, grains of quartz bearing fracture patterns, planar deformation features that can only be produced by the pressure of a nuclear explosion or a cosmic impact event. Nothing else generates sufficient force. Carbon spherules, soot, and at multiple sites, evidence of massive simultaneous wildfires on a scale that could not be explained by ordinary ignition sources. The team proposed that a large, low-density extraterrestrial object, most likely a fragmented comet, had exploded over or impacted the northern hemisphere approximately 12,900 years ago. The resulting shockwave, thermal pulse, and firestorm would have been equivalent to thousands, possibly tens of thousands, of nuclear weapons detonating simultaneously. One event, multiple effects. The megafaunal extinction, the destruction of the Clovis culture, the wildfires, the climate reversal, and the ocean circulation shut down, all of it traceable to a single trigger. The Younger Dryas impact hypothesis was born. The response from the scientific community was, to put it mildly, intense. Critics immediately pointed out the absence of a crater. Proponents responded that a comet fragmenting in the upper atmosphere, an airburst, would not necessarily produce a traditional impact structure. The 1908 Tunguska event in Siberia, where a relatively small extraterrestrial object exploded above the forest, flattened 2,000 square kilometers of trees without leaving a crater. Scale that by orders of magnitude. Critics challenged the nanodiamonds. Proponents refined their methods and found them at more sites across more continents. Critics questioned whether microspherules could have terrestrial explanations. Proponents documented them at over 50 locations spanning North America, Europe, the Middle East, and South America. The same markers, the same layer, the same timestamp. And then came new evidence that made dismissal harder. In 2018, researchers discovered the Hiawatha Crater, a massive impact structure over 19 miles wide, buried beneath 3,000 feet of Greenland ice. Initial age estimates placed it within the Younger Dryas window. Subsequent dating has complicated that picture, and debate continues about its relationship to the event. But its discovery proved one thing definitively: large impacts in this time frame are not impossible. They are documented. In 2025, researchers published findings of a crater-like depression in Louisiana, nearly 1,000 feet long, caused by what appears to have been a cosmic airburst dating to approximately 12,800 years ago. The site contained shocked quartz, glass formed at temperatures exceeding 2,000 degrees Celsius, and microspherular assemblages matching those found at nuclear test sites in New Mexico and Kazakhstan. The signatures were geologically indistinguishable from the aftermath of an atomic detonation. The debate has not ended. The freshwater pulse hypothesis remains the mainstream explanation for the Younger Dryas cooling. The impact hypothesis remains contested, but it has not gone away, and the evidence supporting it has only grown more difficult to dismiss. But here is where the story makes its turn. Because the Younger Dryas impact hypothesis is not just about climate science. It is not just about extinct animals or vanished stone tool cultures. It is about what was lost. If a cosmic catastrophe struck the Earth 12,800 years ago, what was the state of human civilization at that moment? The standard archaeological narrative says hunter-gatherers, small bands, no cities, no agriculture, no permanent structures, simple people living simple lives. But that narrative has been under serious pressure for years, and the discovery that most dramatically challenged it sits on a hilltop in southeastern Turkey. A site that, according to everything we thought we knew about human development, should not exist. Southeastern Turkey. The Cermuş Mountains, rolling hills baked dry under an enormous sky. 15 kilometers northeast of the ancient city of Şanlıurfa, a ridge rises gently from the surrounding plateau. The locals call it Göbekli Tepe, Potbelly Hill. For centuries, the farmers who worked the surrounding land occasionally turned up pieces of worked stone with their plows, carved fragments, geometric shapes, and stacked them along the edges of their fields and forgot about them. In 1963, a joint survey team from Istanbul University and the University of Chicago visited the site. They noted the worked stones, classified the location as a medieval cemetery, and moved on. For 31 years, one of the most important archaeological discoveries in the history of our species sat in plain sight. Dismissed, ignored. Then, in 1994, a German archaeologist named Klaus Schmidt arrived. Schmidt had been searching the region for sites of deep antiquity. When local people directed him to the hilltop, he recognized the stone fragments immediately. These were not medieval. They were prehistoric, and they were extraordinarily old. He began excavating in 1995. What came out of the earth took years for the archaeological world to fully comprehend. Massive T-shaped limestone pillars, some standing nearly 16 feet tall, some weighing as much as 20 tons, arranged in circles, embedded in walls of smaller stones, and covered with intricate carvings. Foxes, lions, boars, snakes, vultures, scorpions, cranes, and ducks. Abstract geometric symbols. And on some pillars, arms carved in relief running down the sides of the stone, with hands clasped at the front, as though the pillars are stylized representations of beings. Giant stone figures standing in circles, facing each other in the dark. The circles are enormous. The largest measures roughly 66 feet across. Each enclosure contains 2 central pillars that are taller and more elaborately carved than the surrounding ring. 20 such enclosures have been identified through geophysical survey, though only a fraction have been excavated. What lies beneath the rest is, at this moment, unknown. And the date. Radiocarbon analysis placed the oldest structures at Gobekli Tepe at approximately 9,500 BCE, 11,500 years ago. More than 6,000 years before Stonehenge. More than 6,000 years before the Egyptian pyramids. Older than any permanent human structure known to exist anywhere on Earth, 11,500 years ago. Before agriculture, before pottery, before metalwork, before the wheel, before writing, before every element of what we traditionally define as civilization. The people who built Göbekli Tepe were, according to every other available line of evidence, hunter-gatherers. They quarried limestone blocks weighing up to 20 tons from outcrops hundreds of yards away. They shaped those blocks into precise T-forms using nothing but flint tools. They carved elaborate animal reliefs into the hard stone, work that required not just technical skill, but artistic sophistication and a complex, symbolic vocabulary. They transported these massive pillars to the hilltop, erected them in carefully planned circular arrangements, and oriented them with a precision that modern analysis has only recently begun to unpack. And they did this not once, not as a one-time convulsion of effort, but repeatedly over centuries, building enclosure after enclosure, each reflecting a coherent architectural vision that implies long-term institutional knowledge, the kind that does not arise spontaneously and cannot be maintained without some form of social continuity. Computer modeling published in the Cambridge Archaeological Journal revealed that the 3 main enclosures at Göbekli Tepe are connected by an equilateral triangle, a geometric relationship that suggests the entire complex was conceived as a single, unified design, not a series of separate structures added incrementally. The builders used rope measurements to establish angles and distances. They worked with a degree of planning and coordination that shatters every assumption we previously held about what hunter-gatherer societies were capable of organizing. Before Göbekli Tepe, the accepted developmental sequence went like this: agriculture first, then permanent settlements, then social stratification, then organized religion, then monuments. Farming creates the surplus that makes everything else possible. Göbekli Tepe reversed that sequence. The temple came before the farm. Long before anyone in the region had domesticated a single grain of wheat or penned a single animal, people were gathering on this hilltop from across a wide region for extended periods to carve and erect massive stone structures dedicated to purposes we do not fully understand. Klaus Schmidt's interpretation was that this very gathering, the need to feed the workers who were building the monument, may have been what pushed people in the region toward the deliberate cultivation of wild grains. Building the temple created the need for agriculture, not the other way around. And there is evidence for this. Just 20 miles from Göbekli Tepe, geneticists found the world's oldest domesticated strains of wheat, dated to approximately 10,500 years ago, about 500 years after construction at the site began. The cradle of agriculture and the world's oldest known temple are neighbors, but the alternative interpretation is equally compelling and significantly more unsettling. What if Göbekli Tepe is not the beginning of something? What if it is the end? What if the architectural sophistication, the organizational capacity, the symbolic vocabulary carved into those pillars did not spontaneously emerge in the minds of nomadic hunters? What if it was inherited? The timing is almost impossibly precise. The Younger Dryas cold period ended approximately 11,600 years ago. The oldest structures at Göbekli Tepe date to approximately 11,500 years ago. The gap between these two events is, in geological terms, negligible. It is as if the moment the cold released its grip, someone, somewhere, began building immediately, urgently, with knowledge they did not have to invent. Among the most famous carvings at the site is Pillar 43, known informally as the Vulture Stone. It depicts a vulture holding a round object, possibly a sphere, in possibly a severed head. Below it, a scorpion. Around it, other animals and abstract symbols arranged in a composition that feels deliberate in a way that is difficult to articulate, but impossible to dismiss. Researchers from the University of Edinburgh analyzed the imagery and proposed that the carvings encode astronomical data, that the animals represent constellations as they appeared in the night sky at a specific moment in time. Using precession calculations, the slow wobble of the Earth's axis that causes the constellations to shift over a 26,000-year cycle, they identified the date the carving may depict, approximately 10,950 BCE, right at the onset of the Younger Dryas. If this interpretation is correct, and it remains debated, then Göbekli Tepe is not just a temple. It is a memorial, a record carved in stone to commemorate a catastrophe, a message from survivors. We remember what fell from the sky. We remember the fire. We remember the cold that followed. A monument built so that whoever came after would know. We move now to Egypt, to the Giza Plateau, to the most recognized monument on Earth. According to mainstream Egyptology, the Great Sphinx was carved around 2500 BCE during the reign of Pharaoh Khafre. The evidence for this dating is largely circumstantial: proximity to Khafre's pyramid, stylistic similarities to Old Kingdom art, and a damaged stele between the paws that may reference the pharaoh's name in a fragmentary and eroded inscription. There is no dedicatory text on the Sphinx itself, no contemporary record of its construction. The attribution is an inference, not a documented fact. For most of the 20th century, no one seriously questioned it. Then, in 1990, a geologist walked into the Sphinx enclosure and saw something that, by his own account, he recognized within seconds. His name was Robert Schoch. He held a PhD in geology and geophysics from Yale. He was an associate professor at Boston University. He had been invited to Egypt by an independent researcher who suspected the Sphinx was older than the official dating and wanted a geologist's professional assessment of the rock. Schoch went, fully expecting to confirm the conventional date. He had no prior investment in an alternative timeline. He was there to do geology. The walls of the Sphinx enclosure, the trench carved into the bedrock, when the Sphinx's body was liberated from the surrounding limestone, showed deep, rounded, or undulating vertical grooves, channels that were wider at the top than at the bottom, profiles that any trained geologist would recognize immediately. Water erosion, specifically, the erosion produced by rainfall running down vertical surfaces over extended periods of time. The Sphinx sits on the edge of the Sahara Desert. The Giza Plateau receives minimal rainfall. The dominant weathering agent in the region is wind-blown sand, and wind erosion produces a completely different signature: horizontal striations, sharp edges, angular profiles. The Sphinx enclosure walls showed something entirely different. Schoch compared the erosion profiles on the Sphinx enclosure to nearby rock-cut tombs from the Old Kingdom, structures that are securely dated to Khafre's era, carved from the same geological formations at the same general location. Those structures showed the expected desert weathering: sharp horizontal layers, wind damage, sand abrasion. The Sphinx and its enclosure showed something different, something that required sustained rainfall, prolonged exposure to heavy rain over a period of centuries. When did Egypt last experience that kind of rainfall? During the African humid period, roughly 12,000 to 5,000 years before the Common Era. During this period, the Sahara was not a desert. It was a green savanna, dotted with lakes and threaded with rivers. Rainfall was abundant. Rock art in what is now the Deep Sahara shows people swimming, fishing, herding cattle beside waterways that no longer exist. If the rainfall erosion on the Sphinx enclosure dates to this period, the monument's core body would predate 5000 BCE. Schoch initially estimated construction before 5000 BCE and later pushed his estimate further, suggesting the core of the Sphinx may date to the end of the last ice age, around 10,000 BCE or earlier, not 4,500 years old, possibly 12,000 years old. The response from mainstream Egyptology was immediate and fierce. Mark Lehner, one of the world's leading authorities on the Giza Plateau, dismissed the hypothesis directly. You do not, he argued, overturn Egyptian history based on a single weathering profile. Salt weathering, periodic wetting from the Nile, moisture in sand that has historically buried the Sphinx up to its neck. All of these mechanisms can produce erosion patterns that superficially resemble rainfall damage. These are legitimate counterarguments. The geology of the Giza Plateau is complex. Multiple weathering processes operate simultaneously, and placing the Sphinx thousands of years before Khafra creates enormous problems for the conventional archaeological timeline. Who built it? There is no evidence in the mainstream record of a civilization in Egypt at 10,000 BCE capable of such an undertaking. Schoch acknowledged these objections and pushed back with additional data. He conducted seismic surveys around the base of the Sphinx, generating sound waves that penetrated the bedrock and measuring the depth of subsurface weathering, how far the erosion extended downward into the rock. The data showed weathering at depths inconsistent with a monument only 4,500 years old, and the pattern was uniform across the enclosure, consistent with prolonged surface exposure to rainfall from above rather than sporadic or localized water sources. He also noted a striking physical detail. The head of the Sphinx is disproportionately small relative to the body. Precise measurements confirm this. The head is too small for the body it sits on, and the tool marks on the head are comparatively recent, consistent with Old Kingdom craftsmanship. This led Schoch and others to propose that the head was recarved, that the original head, whatever it depicted, was severely damaged by millennia of weathering, that a later pharaoh, working during the Old Kingdom, recarved the existing head into its current human form. A smaller head carved from a much eroded larger original would explain both the proportional discrepancy and the difference in tool signatures. One more detail. The Sphinx faces due east. On the morning of the spring equinox, it looks directly at the rising sun, but because of precession, the slow wobble of the Earth's axis over a 26,000-year cycle, the constellation visible on the eastern horizon at sunrise on the equinox changes over time. Today, on the spring equinox, the constellation rising in the east is Pisces. Around 2500 BCE, when Egyptologists date the Sphinx's construction, it was Taurus, the bull. But if you rewind the sky to approximately 10,500 BCE, the constellation on the eastern horizon at dawn on the spring equinox was Leo, the lion, a lion monument facing east, aligned with the constellation of the lion at the moment of the equinox sunrise. The symbolism is too precise to ignore, even if you refuse to accept it as proof of anything. Coincidence? Possibly. But it is a coincidence that has driven serious researchers into decades of argument, and one that no one in the mainstream has definitively explained away. The Sphinx debate remains unresolved. What is not in dispute is that the questions Schoch raised are legitimate geological questions that have not received fully satisfying geological answers. And if the Sphinx is 12,000 years old, what else might be? Two artifacts, two anomalies separated by geography and by type, one drawn on the surface, one carved beneath it, both, in their different ways, pointing at the same uncomfortable possibility. Let us take them in order. In 1929, in the basement of the Topkapi Palace in Istanbul, the former administrative center of the Ottoman Empire, a German theologian named Gustav Adolf Deissmann was cataloging neglected documents when he pulled a rolled piece of animal skin from a dusty shelf. It was gazelle hide, dried and aged. He unrolled it carefully. What he found was a fragment, clearly about 1/3 of a much larger chart, drawn and signed in 1513 by an Ottoman admiral and cartographer named Haji Ahmed Muhiddin Piri, known to history as Piri Reis. Piri Reis was a serious man, a former privateer who had served in the Ottoman Navy, a devoted collector of geographical intelligence, and a skilled cartographer in his own right. In annotations written directly on the map, he explains that he compiled it from approximately 20 source charts, 8 Ptolemaic maps based on ancient Greek geographical knowledge, 4 Portuguese charts from recent Atlantic explorations, an Arabic chart, and, he claims, a chart drawn by Christopher Columbus himself, a document now lost to history. The Piri Reis map depicts the western coast of Africa, the Iberian Peninsula, and the eastern coast of South America with a degree of accuracy that impressed 20th century cartographers when they first studied it seriously. The Brazilian coastline, in particular, is rendered with notable fidelity for an era in which the full extent of South American geography was still being actively explored. But the feature that launched this map into the realm of genuine mystery is at the bottom of the fragment. Below the South American coastline, the map depicts a large landmass extending to the south and curving eastward. A landmass that, to certain eyes, looks unmistakably like the northern coast of Antarctica. Antarctica was not officially discovered by European explorers until 1820, more than 300 years after Piri Reis drew his map. In 1965, Professor Charles Hapgood of the University of New Hampshire published Maps of the Ancient Sea Kings, in which he argued that the southern landmass on the Piri Reis map was not just a depiction of Antarctica, but of Antarctica without its ice cap, showing a subglacial coastline that was only mapped in the 20th century using seismic surveys and satellite imaging. If Hapgood was right, the implications were extraordinary. Someone at some point before the ice-covered Antarctica had mapped its coastline, had possessed the navigational capability to reach a continent at the bottom of the world, the cartographic skill to record it accurately, and some means of transmitting that knowledge forward through time until it arrived, via a chain of increasingly degraded copies, in Piri Reis's hands in 1513. Hapgood proposed that the source of this knowledge was an unknown ancient civilization, technologically capable, maritime in orientation, advanced enough to navigate the world's oceans and produce accurate charts thousands of years before the Greeks. His book attracted attention from unexpected quarters. Albert Einstein, in the foreword to an earlier Hapgood work, praised the originality of his thinking and the seriousness of his methodology, though he did not specifically endorse the ancient Sea Kings hypothesis. But the Piri Reis map is a more complicated artifact than mystery enthusiasts typically acknowledge, and intellectual honesty requires stating this clearly. The identification of the southern landmass as Antarctica is contested by mainstream cartographic historians, who argue that it is more likely a distorted depiction of the southern tip of South America. In the early 16th century, the complete southern extent of South American geography was still unknown, and cartographers routinely extended coastlines based on speculation or on the classical Greek assumption, inherited from Ptolemy, that a large southern landmass must exist to balance the northern continents. This hypothetical terra australis appears on numerous maps of the era, none of which were drawn from actual observation of the Antarctic continent. Piri Reis may simply have been following this cartographic convention. Moreover, Hapgood's claim that the map shows Antarctica without ice has been seriously challenged. A geophysical survey of Antarctica conducted in the 1940s and 1950s, which Hapgood relied upon, covered less than 1% of the territory depicted on the map. Later and more comprehensive surveys found no significant correspondence between the Piri Reis coastline and the actual subglacial topography of Antarctica. Modern ice core data indicates Antarctica has been covered by ice for at least 10 million years, far longer than Hapgood assumed, and the annotations Piri Reis himself wrote near the southern landmass describe it as uninhabited, hot, and populated by large snakes, a description that fits the tropics, not the Antarctic. The scholarly consensus is that the Piri Reis map is a remarkable but ultimately explicable product of 16th century cartography. It is not evidence of an advanced ancient civilization, but the question it raises, why do so many early maps include a substantial southern continent, and why do some of its features bear any resemblance, however imprecise, to the actual geography of Antarctica, does not go away simply because the most dramatic interpretation has been debunked. The map alone cannot carry the weight of a lost civilization, but it fits a pattern. It is one more anomaly, one more thread that does not quite slot into the conventional frame. Now, let us go underground. 1963. A man in the Turkish town of Derinkuyu, in the volcanic heartland of central Anatolia, is renovating his house. He picks up a sledgehammer and swings it into a basement wall. The stone crumbles. Behind it, darkness. Not the darkness of a crawl space. Something deeper. He pushes through the debris and finds himself at the entrance to a tunnel. The tunnel leads to a room. The room connects to another tunnel. That tunnel descends to another room, and another, and another, going down. What this unnamed homeowner had broken into was one of the most extraordinary archaeological discoveries of the 20th century, an entire underground city, carved from the soft volcanic tuff of the Cappadocia region, extending approximately 85 meters, roughly 280 feet, into the earth, 18 levels deep. Derinkuyu was not a hole. It was a city, a fully engineered, strategically designed subterranean community capable of sheltering up to 20,000 people, along with their livestock and enough food stores for an extended period of isolation. It contained ventilation shafts, a network of precisely calculated airflows running from the deepest levels to the surface, maintaining breathable atmosphere throughout. Some of these shafts doubled as wells, penetrating down to the water table. Even at the lowest levels, the air remained clean. It contained stables, storage rooms, kitchens, meeting halls, schools, wine and oil presses, and chapels. Massive circular stone doors, each weighing several hundred pounds, could be rolled across corridor entrances from the inside, sealing the city. They could not be opened from outside. The corridors were deliberately narrow, forcing any invaders to move single file, where they could be picked off by defenders. Every floor could be independently sealed. If the upper levels fell, the population could retreat deeper, closing stone doors behind them at each level. This is not the work of frightened villagers digging a hole to hide in. This is the work of engineers, people who designed the ventilation system before the first shaft was excavated. People who calculated structural loads, mapped the water table, and coordinated the labor of hundreds or thousands of workers over what must have been decades, if not centuries. Derinkuyu is not alone. Cappadocia contains over 200 known underground settlements. Some are small, 2 or 3 levels. Others rival Derinkuyu in scale. Just 5 miles away, the underground city of Göbekli may have once been connected to Derinkuyu by a tunnel stretching nearly 9 kilometers. In 2015, during construction of a housing project near the town of Nevşehir, another underground city was discovered beneath a hilltop castle. Initial surveys suggesting it could be even larger than Derinkuyu, extending over 100 meters deep and covering nearly 5 million square feet. What were they hiding from? The conventional explanation is well supported and reasonable. Cappadocia sits at a crossroads of empires. Hittites, Persians, Greeks, Romans, Byzantines, Arab armies, Mongol raiders all passed through the region over thousands of years. Historical records confirm the underground cities were used as refugees during Byzantine Arab conflicts and during the Mongol incursions of the 14th century. The early construction is generally attributed to the Phrygians, who inhabited the region in the 8th and 7th centuries BCE. Later cultures, particularly Byzantine Christians, dramatically expanded the complexes. This explanation is rational. It is evidence-based. For the historical periods we can document, it answers the question adequately. But it raises a question of scale. You do not need to go 18 stories underground to hide from a cavalry raid. A few levels would serve. The extreme depth suggests that whoever designed the deepest portions was not preparing for a passing army. They were preparing for a scenario in which the surface itself became uninhabitable for an extended period. Something that made the sky dangerous. Something that required going deep enough to wait it out. Some researchers have proposed a connection to the younger Dryas. Göbekli Tepe lies roughly 600 kilometers to the east. Both regions show evidence of human occupation during the same broad period. If a cosmic catastrophe filled the sky with dust, soot, and debris, triggering firestorms, global cooling, and years without reliable sunlight, then going underground is not a metaphor. It is a survival strategy. This theory is speculative. There is no direct archaeological evidence linking Derinkuyu's deepest levels to the younger Dryas impact event or to any specific cosmic trigger. The conventional dating places the known construction far more recently, but the theory persists because it addresses the question of scale in a way that conventional explanations do not. Why dig 18 floors into the rock unless you had a reason to fear the surface itself? There is a story. You have heard it. You probably know it by several names. The gods grew angry, or despairing, or simply tired, and decided to start over. They sent the water. The world drowned. But one person, or one family, or one small group survived. On a boat, or a raft, or a mountain. They waited until the water receded. They sent out birds to find dry land. They came down from the high place and began again. They repopulated the world. They built a new civilization from the ruins of the old. This is one of the most universal stories in human culture, and it appears, with striking structural consistency, in the oral and written traditions of cultures that had no known contact with each other. On every inhabited continent, in every major linguistic family, among peoples separated by 10,000 miles of ocean. The most ancient written version comes from Sumer, the civilization that arose in southern Mesopotamia around 5,000 years ago. In the Epic of Gilgamesh, the greatest surviving work of ancient literature, the hero Gilgamesh travels to find Utnapishtim, the only human ever granted immortality. Utnapishtim tells him how he survived the Great Flood, a divine warning, a boat, 6 days and 7 nights of storm, mountains of bodies floating in the water, a final landing on a mountain, birds sent out to find dry land, a dove that returned, a swallow that returned, a raven that did not come back because the waters had begun to recede. The parallels to Genesis are not coincidental. Scholars have long recognized that the biblical flood narrative was influenced by the older Mesopotamian tradition. The earlier Atrahasis epic and the Sumerian Eridu Genesis tell similar stories with different names and different details, all predating the Hebrew text by centuries. But the Mesopotamian versions are themselves just one branch of a much larger tree. In Hindu tradition, the god Vishnu warns the sage Manu of an approaching flood. Manu builds a boat, loads it with seeds and the preserved wisdom of the Vedas, and survives, towed through the rising waters by a great fish. From the aftermath of the flood, Manu repopulates the world. In Greek mythology, Zeus decides to destroy humanity with a flood. Deucalion and Piri, the only righteous couple, survive in a chest that floats on the rising waters. When the flood recedes, they land on a mountain and repopulate the earth by throwing stones over their shoulders, which become new people. In Chinese tradition, the sage gun attempts to stop a great flood by building dams and fails. His son Yu succeeds by dredging channels. The flood is the foundational civilizational trauma of Chinese historical memory, and Yu becomes the first ruler of the Xia dynasty. In Norse mythology, the world itself begins with a flood, the blood of Ymir, the primordial giant, from whose remains the gods form the earth. Among Aboriginal Australians, flood stories are among the oldest continuously maintained oral traditions on the planet, with some accounts corresponding to geological evidence of post-glacial sea level rise along specific stretches of the Australian coast. Researchers studying these accounts have suggested that certain Aboriginal flood narratives preserve accurate memories of real events dating back 10,000 years or more. Memories transmitted orally across 300 generations without being written down. In the Americas, the Hopi describe a world destroyed by water because the people had become corrupt. The Aztec cosmology includes a fourth sun, a previous age of the world, that ended in catastrophic flooding. The Maya Popol Vuh describes the destruction of an earlier creation by a flood sent by the gods. South American indigenous traditions from the Andes to the Amazon contain similar accounts. Scholars have cataloged more than 500 distinct flood myths from cultures around the world. 500 distinct traditions, many from cultures with no known contact with Mesopotamia or with each other. Different languages, different cosmologies, different geographies, the same story. The mainstream anthropological explanation for the universality of flood myths is, on the surface, elegant. Floods are a universal human experience. Nearly every human settlement in history has been built near water, rivers, lakes, coastlines, because water is essential for survival, for agriculture, for trade. Water floods. It always has. Every culture that lives near water has experienced catastrophic local flooding at some point, and those local disasters become mythologized over generations, growing in scale and significance until they are framed as world-ending events. The flood myth, in this view, is a natural product of the human condition. An independent invention, repeated across cultures because the underlying experience, water destroying everything you have built, is universal. This explanation has real merit. Humans are narrative creatures. We explain existential threats through story. We mythologize our traumas. The psychological mechanism that produces a flood myth is well documented and present in every culture that has ever existed. But the explanation struggles with something the critics of the universality thesis cannot easily dismiss: the specificity of the structural parallels. It is not just that different cultures tell stories about floods. It is that they tell stories about floods with the same internal architecture: a divine warning, a chosen survivor, a vessel built for preservation, animals or seeds saved, a mountaintop landing, birds sent to scout for dry land, a sacrifice of gratitude, a new beginning. These structural details, not just the event, but the specific narrative beats, recur across cultures that had no apparent means of sharing stories. The number of independently invented epics with the same protagonist, the same warning scene, the same bird motif, and the same covenant of renewal would be a remarkable coincidence. Unless, of course, they are not independent at all. Here is an alternative hypothesis that deserves serious consideration, stripped of mythology. These stories are memories, not of a single simultaneous global flood. The physics do not support that, and there has never been enough water on Earth to cover all land simultaneously. But memories of a process. A prolonged, devastating process that affected coastlines and river valleys around the world over thousands of years. At the end of the last ice age, beginning roughly 15,000 years ago and continuing until approximately 7,000 years ago, global sea levels rose by over 120 meters, nearly 400 feet. Coastlines that had been stable for tens of thousands of years were submerged. Entire landmasses disappeared beneath the waves. The land bridge between Asia and North America submerged. The vast continental shelf connecting Britain to continental Europe submerged. The Sunda Shelf between Southeast Asia and Indonesia submerged. A landmass the size of India lost beneath the sea. The continental shelves of India, Australia, and the Americas all drowned. The transformation was not uniform. While the overall trend was gradual, it was punctuated by episodes of extremely rapid flooding, meltwater pulses, sudden releases of enormous volumes of water from collapsing ice sheets or bursting glacial lakes that could raise sea levels by several meters in the span of decades. For coastal populations, such pulses would have been apocalyptic in local terms. Imagine a community living on the coastal plain 12,000 years ago. They have lived there for generations. The sea provides everything: their culture, their religion, their architecture, all oriented toward a water. Then the water begins to rise. Slowly at first, the beach moves a few yards closer each generation, then faster. A storm surge that once retreated now does not. Fields flood. Wells turn brackish. Within a lifetime, the land their grandparents farmed is underwater. Within a few more generations, the village itself is gone, and the only memory of it is a story about a time when the water came and took everything. Now multiply that by every coast on every continent. Repeat it across 8,000 years of rising seas. Layer upon layer of loss, generation after generation, watching the ocean swallow their world. Is it any wonder that every culture remembers a flood? And is it coincidence that the structural details of survival, boat, mountain, birds, beginning again, are so consistent across cultures that experienced real versions of these events? And here is the final, most important dimension of this. If there was a civilization before our own, even a partial one, even a proto-civilization more advanced than the standard archaeological narrative allows, where would it have been? Not in the highlands, not on the mountains. Civilizations develop along coasts and rivers, along the paths of trade and communication, in the places where food is abundant and transport is easy. The coastlines of 12,000 years ago are now under 400 feet of water. We have not looked there. Not seriously, not systematically. Marine archaeology is extraordinarily expensive, technically challenging, and limited in scope. A handful of intriguing sites have been investigated. Submerged structures off the coasts of India, Japan, and the Mediterranean have been reported, though their origins and significance remain debated. The drowned landscapes of Doggerland, the land bridge between Britain and continental Europe, have yielded some tantalizing artifacts, but the vast majority of the world's submerged continental shelves, the lands where any Ice Age coastal civilization would have lived, remain entirely unexplored. If the evidence exists, it is there, under the water, under the sediment, under 12,000 years of silence. We are not even looking. We are at the end of the journey. Or perhaps, and this is the part I want you to sit with, we are at the beginning of one. The Earth is 4.5 billion years old. Complex life has existed here for over 500 million years. Intelligent, social, tool-using animals have shared this planet with us and our ancestors for tens of millions of years. Our species, Homo sapiens, has existed for approximately 300,000 years. Our industrial civilization has existed for 300 years out of 4.5 billion. We know that the geological record is incomplete, that tectonic processes recycle the ocean floor every 200 million years, that erosion, subduction, metamorphism, and time systematically destroy surface evidence across millions of years. That chemical signatures produced by industrial civilization are, in most cases, indistinguishable from chemical signatures produced by natural geological events. We know that the PETM 56 million years ago produced a carbon isotope anomaly in the rock that is the closest known ancient analog to what modern industrial civilization is doing to the planet, and that its exact trigger remains debated. We know that something catastrophic happened 12,800 years ago, that the megafauna of multiple continents went extinct simultaneously, that a culture of sophisticated human beings vanished, that a growing body of multidisciplinary evidence, from nanodiamonds to shocked quartz to cosmic glass, suggests an extraterrestrial impact event played a role, though this remains contested. We know that Gobekli Tepe exists, that it was built 11,500 years ago by people who, by every other available metric, should not have been capable of building it. That its sophistication implies inherited knowledge, a tradition, a body of technical and symbolic understanding that did not emerge from scratch. We know that the Great Sphinx shows erosion patterns that at least some qualified geologists attribute to prolonged rainfall in a desert that has been arid for thousands of years before the conventional date of its construction. We know that virtually every culture on Earth tells a story about a catastrophic flood that destroyed the world and forced civilization to begin again, and that the geological record confirms a prolonged, global sea level rise that would have devastated coastal populations worldwide for 8,000 years. We know that the submerged continental shelves of the Ice Age world, the most likely location for any pre-Ice Age coastal civilization, remain almost entirely unexplored. None of this is proof. The conventional explanations for each of these phenomena are reasonable, well supported, and in most cases, probably correct. But taken together, they form a pattern of anomalies, a pattern of things that do not quite fit. Let us do what Frank and Schmidt intended their hypothesis to do, not as an assertion, as a thought experiment. Imagine a civilization that arose during the Ice Age, not identical to ours, but comparable in some ways, maritime rather than terrestrial, oriented around the coasts, the rivers, the paths of the sea, advanced in astronomy and navigation, capable of organized agriculture, were able to coordinate large-scale communal projects, possessed of a symbolic system rich enough to encode complex information in carved stone, not a civilization of skyscrapers and smartphones, a different kind, one that developed along different lines, at a different pace, leaving a lighter technological footprint than we do. Imagine that this civilization, 12,800 years ago, was struck by a catastrophe. A comet, a fragmented bolide, something from the sky, fire and cold and a darkened sun, rising seas that drowned their coastal cities within generations, a collapse so swift and so total that within a few centuries the survivors were scattered, the institutional knowledge fragmented, the records destroyed. But not everyone died. Some survived. Some carried pieces of what had been lost. Fragments of astronomy, fragments of agricultural practice, fragments of architectural knowledge, fragments of a symbolic vocabulary, and found their way to populations that had not been touched by the worst of the catastrophe. Imagine that those survivors built Göbekli Tepe as a memorial, a record in stone for whoever came after, a way of saying, we remember the fire, we remember the cold, we remember what we had before. Imagine that they carved the Sphinx as an astronomical marker, aligned to a moment in the sky that will not occur again for 26,000 years, a cosmic timestamp embedded in the bedrock. Imagine that their maps, their charts, their encoded knowledge of the world's geography filtered down through thousands of years of copying and recopying, degraded, distorted, partially understood, until fragments of it appeared in a collection of source charts consulted by a Turkish admiral in 1513. Imagine that the flood myths of Sumer and India and Greece and the Americas and Australia are not independent inventions. They are memories of real water, real loss, transmitted across 300 generations by people who had no other way to preserve what they knew. And imagine that the evidence of their civilization lies exactly where it should be, under the ocean. Under 120 meters of water and 12,000 years of marine sediment on the drowned continental shelves that we have not yet systematically explored. This is the story that alternative researchers have been trying to tell for decades. And it is a story that mainstream science, for good reasons, has largely rejected. Extraordinary claims require extraordinary evidence. The evidence, while suggestive, is not yet extraordinary. It is circumstantial. It is interpretive. It requires choosing specific readings of ambiguous data. The rejection is not unreasonable, but the rejection is not the final word either, because science is a process, not a conclusion. And the history of science is littered with orthodoxies that collapsed when the right question was finally asked. For centuries, the most parsimonious explanation for the diversity of life was special creation. For decades, the most parsimonious explanation for the continental shapes was coincidence. For years, the standard explanation for the end of the dinosaurs was gradual climate change, until a crater in Mexico proved that sometimes the universe throws rocks at us. Frank and Schmidt were explicit. They did not believe a previous industrial civilization existed. The Silurian Hypothesis was not an argument for lost civilizations. It was an argument about the limits of knowledge. What it tells us is not that something was here before us. It tells us that we cannot be certain something was not. And in science, that distinction matters enormously, because the absence of evidence is not the evidence of absence, especially in a system specifically designed by its own geological processes to destroy evidence over millions of years. We have been so certain of our own uniqueness, so confident that consciousness and civilization and the drive to build and understand arose precisely once, in precisely us, in the final 4 seconds of the Earth's year. That certainty may be warranted. The simplest interpretation of the available record is probably correct. We are the first. But it is a certainty built not on proof, but on the limits of our ability to see. First, keep looking. The submerged continental shelves represent one of the largest unexplored archaeological frontiers on the planet. As sonar technology improves, as autonomous underwater vehicles become more capable and more affordable, as marine archaeology matures, we will begin to map those drowned landscapes. What we find there will either change everything or confirm what we already believe. Either way, we need to look. And we need to fund the looking. Second, keep questioning. the linear narrative of human progress, from primitive hunter-gatherers to sophisticated civilization in a neat upward line, is a story we tell ourselves. It is not the only story the evidence supports. Göbekli Tepe alone should make us humble about what we think we know about our ancestors. If they could build that, what else could they do that we have not yet found? The archaeological record is not complete. It is a Swiss cheese of gaps and absences. Only a tiny fraction of the Earth's surface has ever been excavated. We are reading a partial text and calling it the whole story. Third, and this is the one that matters most, right now, in this moment in history. Take the warning seriously. Whether or not a previous civilization existed, the Silurian Hypothesis carries a message that is absolutely relevant to us right now. We are leaving a mark on this planet, a deep, indelible chemical mark. We are changing the atmosphere. We are changing the ocean chemistry. We are driving species to extinction at a rate that matches the great mass extinctions of the deep past. We are, in geological terms, creating our own PETM. And if we do not change course, the question that a future intelligence might ask, looking at the thin chemical layer we leave in the rock, is not whether we existed. It will be, what happened to them? The Earth does not care about us. It does not care about our cities or our art or our arguments about lost civilizations. It spins and shifts and erodes and subducts and recycles, regardless of what we do. It has done so for 4.5 billion years. It will do so for billions more. The question is not whether the Earth will survive. It will. The question is whether we will leave anything behind that matters, or whether, like the hypothetical civilization of the Silurian Hypothesis, we will be reduced to a thin, ambiguous line in the rock, a chemical whisper, a signal that some future species might find and wonder about if they are wise enough to ask. The Egyptian pharaohs carved their names into stone because they understood something we are still learning. That time erases almost everything, and only the things we deliberately protect have any chance of surviving. The builders of Gobekli Tepe created something so extraordinary, so far beyond what their supposed capabilities should have allowed, that it survived 12,000 years of burial, 12,000 years of silence, and emerged into our century as a monument to human capacity that we still cannot fully explain. The people who told the flood myths passed their stories down across 300 generations, not because they had nothing better to do, because they understood that memory is the only form of immortality available to biological creatures, that stories outlast stone when stone has no one to protect it. We remember what we choose to remember. We forget what we fail to protect. So the next time you look up at a clear night sky and see the band of the Milky Way stretched above you, or stand on a beach and watch the waves erase your footprints in the wet sand, or hold a handful of soil and consider, for a moment, all the life that has passed through it over 4.5 billion years of Earth history. Ask yourself this question: if someone came before us, what did they want us to know? And if no one did, what do we want to leave for whoever comes next?